Hello, everybody. It is absolutely marvelous to be presenting here the joys of ride-on model railway signaling using Kubernetes. I would, under any other circumstance, have a live demo in this particular slide deck for you, but unfortunately, I currently have a very blown-up boiler sitting in the background behind me and a not insignificant amount of copper piping, which I am currently in the process of reattaching to said boiler. But I do have a whole ton of very fun things to talk to you about when it comes to this. So let's kick this off very, very quickly. Who am I? Well, I am John. I do various snow sportsy things. I also do various train-related things as of the last half year or so. And I am well known for basically breaking things. In my off time, I am a professional blow things up-over, which I think kind of comes along with the whole corner of, for example, tiny steam locomotives. And I am a semi-professional buddy dad. I have to get him in here, otherwise he will never let me live this down. So, model train signaling. So this is kind of an interesting topic because everyone, when you kind of say model trains and you kind of think about that, you usually think of, like, for example, like N gauge or like double O gauge, that corner of things. That is not quite what we're talking about today. We are talking about something a little bigger, as the ride-on section of the title may imply. We are talking specifically about trains in the 5 1/4 or 7.5 inch gauge variety. And these are of the size that you can kind of fairly feasibly build either in a small garden or anywhere else. A lot of conferences do tend to have tracks for these. Yes, that's my new favorite pun. Keeping an eye on the chat there. But these are some very interesting little bits of kit because they are probably one of the most accessible sizes that you can get for kind of model locomotives when you get outside of the kind of really model section. And this, for example, is one of my local model railway, and they, for example, have a whole bunch of various tracks that run around this little garden center that they have, and they have at least two or three different sections, of which the point is that they have a couple of different options in terms of how they route trains. And there's a ton of big, complicated things that you can do with train signaling. But one of the main concepts that you get is this idea of blocks. So this is applicable basically to all general methods of doing train signaling. In this instance, we're specifically applying it to models. So the way that this operates effectively is that you separate each section of your track into a block, and a block can have a single section of a train within it. The idea being that when a train goes into a block, that section of track is then effectively locked. There is no other trains should be able to go into that section of track until the train that has entered has subsequently left again. And the whole point of this is effectively to very simply avoid having trains decide to magically disappear into one another, as they occasionally tend to do if you don't control them. And one of the main ways that train signaling operates is using these little devices called axle counters. And like the name implies, they count the number of members of AC/DC that go through them as they pass by. The way that operates is that you have one of these at the entrance and exit to a section of track, and for every wheel and train axle that basically goes through it, it counts it. And then in order to figure out whether the line is clear, it will compare the number of axles going in and the time to determine the speed and if the train has cleared the area. It's a pretty simple concept. it's used in a combination with your like signaling control stuff, and which, by the way, I am going to be open sourcing a very fun signaling control, system in React a little bit later down the line once I have that fully together. Yes, it was in was in fact Guns N' Roses, not AC/DC. Completely slipped my mind there. But yeah, this is also coupled into safety interlocks. If you happen to have gates to cross the track, for example, that can be used to notify the driver. That's especially useful on the model scale because you are invariably going to come across a situation where somebody is going to need to go across your very small track that you have definitely not laid directly across your front door because that was the only like solid piece of concrete that you could find. And in that instance, you probably want to make sure that you don't run them over at the horrific speed of 4 miles an hour. So, how would you roll the hardware for this setup? Well, building your own axle counters isn't too hard. In my instance, I have been working on some 3D print files for them, run them up in resin, mainly because you don't want to do that type of stuff in anything that isn't UV resistant because they're going to be outside the entire time. And you have a main kind of section of stuff, right? You have your on-train hardware, in order to handle your kind of general operation. You then have individual nodes that are split out across the network. So you've got your signals, you've got your points control if you're doing automatic point switching, you have your safety interlocks for things like your gates and sections where you're doing axle counting, for example. And we have a ton of these different nodes on this network, and they're all doing various discrete tasks. So looking at this from a software engineered perspective of things, took a look at this and immediately thought, let's put all of this on Raspberry Pis because obviously. But secondly, the second solution here, well, the biggest question here is you have a whole ton of stuff across a very large section of land, and you're trying to get power to all of it. And the last thing that you want to do is to just kind of say screw it and electrify the rails, because that invariably tends to go very, very badly. So the solution to this is power over Ethernet. So you can, in fact, fairly easily, if you go for some of the newer AF specs, get PoE to run over very, very long distances. So once you have gone full steam ahead and networked all of your nodes together, you then have, like I say, the problem of how to deploy all of these individual pieces together. You have your on-train hardware, which is the bit that actually shows the driver how to whether stuff is in fact driving correctly. You have your hardware on the signals themselves. You have your axle counting. And you have your points in this specific instance. And each one of these I am deploying as its own discrete microservice. Because the great thing about microservices, among other things, is that you can deploy them on hardware as well as software. I actually kind of got the idea for this from, there's a really good article that I would highly suggest you go and look up that is talking about, I think it's In-N-Out, one very large US fast food company that was actually using Kubernetes to do deployments to hardware in all of their kitchens, and basically push software updates to all of it almost on a like 4 times daily basis. So yeah, the solution is to run what's called micro Kubernetes. So this is a build of it specifically designed to run on Raspberry Pis, and effectively allows you to go ahead and effectively route everything throughout. The flip side of it as well is that we then have to have some of the UI components, which is done through a combination of React and the worst JavaScript that God hath wrought upon the earth. But yeah, there's a reason that I'm open sourcing that later. It currently looks like somebody has someone's run a train through it, actually, unsurprisingly. And finally, at the end of all of this, in the joyous fun that we get off the back of it, is this giant horrific hellscape of a network where we have effectively a console-backed service discovery system running on a train, which then learns every single attached piece of infrastructure, picks up all of the associated nodes, and then communicates with the wider network using a local LoRa network. If anyone is familiar with that, that is a very nice little low power Internet of Things network system that you can use. So, right, finally, why does this all matter? Well, safety systems are incredibly important because occasionally you will get situations where your trains will magically forget that they are in fact supposed to be more than 8-bit and have more than 256 axles on a train, and then magically your train will disappear. You do not want this to happen, especially if it happens to be in your garden. Thank you very much. I have just barely hit time on this. I'm frankly not quite impressed that I managed to at all. If you would like to find out more about all of the fun Steam Train and non-Steam Train related things I'm doing, you can find me on Twitter. I also stream on Twitch under the same name, and I am currently working on a desktop flamethrower. So if you want to know more, please do come along and say hi. Thank you very much, and stay safe out there.